Hello, everyone, and welcome to today's webinar, Your Recipe for Growth, Achieving Higher Yields, Revenue Cycles, and Crop Quality with Light Control, which is brought to you by Heliospectra. I'm Robin Sitberg with Meister Media Worldwide, publisher of Greenhouse Grower magazine. We're going to hear today how Greenbelt Microgreens is profitably scaling their operation by gaining control over year-round light levels. By working with experts from Heliospectra and implementing their light management system, Greenbelt achieved consistent year-round yields and sales while minimizing energy and labor costs. We'll hear from Greenbelt's head grower and from two of the people she worked with at Heliospectra. We'll have time for some questions and answers after the presentation. If at any time during the presentation you'd like to ask a question, just type it in the question pane at the lower left panel of your presentation window and click Submit. Your question will go into a queue, and we'll do our best to answer as many questions as we can at the end of the presentation. So I'd like to introduce our presenters for the webinar. We have three. Karin Dankes is Product Manager for Heliospectra, and she's joining us from Sweden. She drives the conception, development, and management of LED-based technology products that are ushering in a new era of spectral control for the company. Karin has a bachelor's degree in automation and mechatronics engineering and a master's degree in product development from Chalmers University of Technology in Gothenburg, Sweden. Alice Ferris is head grower for Greenbelt Microgreens in Hamilton, Ontario, Canada. Greenbelt Microgreens is Canada's largest grower and distributor of organically grown microgreens and lettuce. Alice and the Greenbelt team have created truly sustainable cultivation and business methodologies to take fresh-picked, flavorful, and nutritious products to market in the Toronto area. And our third speaker is Dr. Fei Jia, Technical Sales Engineer for Heliospectra. Fei completed his postdoctoral research and extensive work with sensors and instrumentation for agricultural applications at the University of Arizona's CEAC program in Tucson, Arizona. Today, Fei enjoys providing technical support and assisting customers with Heliospectra lighting strategies and installations all across North America. They have a lot of information to share, so now I'm pleased to turn the program over to Karin.
Thank you, Robin. We're happy to be joining you today, and we're happy to have so many people be online with us talking about different types of greenhouse technologies and our Heliospectra offering into this market sphere, and how greenhouses and growing environments are becoming more and more connected and resource efficient. And we're even happier today to have such a great partner such as Greenbelt Microgreens being part of the webinar with us today. So we first learned of Greenbelt Microgreens from scientists at the University of Guelph. Both of our companies were collaborating with the university, and a scientist there named David Llewellyn of the university described an operation to us that was really committed to efficiency in absolutely every respect and to quality. They really expect the quality from themselves and from their vendor partners. So we instantly recognized a really great fit by working with them. And really, all you have to do is to look around the Greenbelt facility from the state-of-the-art acrylic roof that permits UV transmission and right down to the compostable trays. And really helps you understand how that this is really a company that understands efficiency. So we were really excited to be working with them. And and even more excited to have such a great partnership where we have been able to find so many things from Greenbelt. And we're really happy to have Alice join us here today. So with that, I'd like to introduce Alice Ferris of Greenbelt Microgreens.
Thank you, Karin. Greenbelt Microgreens was founded by Ian Adamson, who's pictured on the top left-hand corner of your screen. He founded this business in 1998. His vision really makes the company what it is today. He wanted to grow healthy, local, organic food that could be available to everyone at store level. Microgreens was his crop of choice, and a state-of-the-art acrylic greenhouse seemed to be the best way to do that. The company has seen some aggressive growth and purchased its 3.5-acre greenhouse in 2016. Organic production is Ian's method of choice. Our organic fertility is key to providing a healthy microbial balance within our media, allowing for a stronger and healthier plant, both to grow and to eat. Sustainability is an important aspect for our company. We collect all the rainwater from our roof, and 100% of that water is recycled within our facility. We also supplement with solar energy. We have a lot of innovation and automation, as Karen pointed out, in our facility. We use a conveyor-driven soil production line, seed line. We have automated watering booms, automatic harvesters, pack line. That all of these things allow for the growing and packing of our microgreen products to be done efficiently and quickly, with the aim of enhancing our quality and increasing our shelf life. But the key to all of these things is our team. We work together like a family, and we live and work locally. So we grow organic lettuce and microgreens. Microgreens are small versions of larger plants. So we have about 15 varieties of microgreens, and we grow things like sunflowers, pea, and broccoli. And we also mix our microgreen products with lettuce to provide many options for our customers. Our crops are specifically chosen with our customers in mind, and we are continually trialing new products. We grow in a living soil that allows for a stronger and healthier plant as nature intended. We harvest and package our products on site and sell to all of our major local grocery store chains. Our growing and production methods give our products more flavor and a longer shelf life. So, seasonal differences in light really can affect our quality and our crop time, as well as our harvest yields. Some of our greens can change in quality in the winter months. Microgreen leaves tend to grow thinner and are more delicate during the short, dark days of winter. Our crop cycle is also very short, which makes us particularly vulnerable to seasonal and daily changes in light. Quite simply, we receive less hours of light and less light intensity in the winter than we do in the summer. This creates challenging seasonal swings in our production numbers and our greenhouse space planning. For example, our shortest crop is 4 days long. In the height of summer, this crop receives 62 hours of natural sunlight. In the dark of winter, it takes almost 7 days to receive the same amount of light. This lengthens our crop time, and you can imagine what it does to the volume of crop growing in our greenhouse, summer compared to winter. In addition to this challenge, our harvest yields also decrease during short days. We harvest fewer grams per tray, which requires the seeding of more crop in the winter. For arugula, this seasonal difference has been up to 120 grams of product per tray, requiring more trays to be seeded and taking up more space in the winter in the greenhouse. These issues together cause our greenhouse space allocation to change drastically. We require 30% more square feet in the winter in the greenhouse for the same sales volume than we do in the summer. So we quickly saw supplemental lighting as a very feasible option for our business. For Greenbelt Microgreens, it was never a question of if we required supplemental lighting, but when we would do it. Seasonal supplemental lighting maintains our crop quality and allows us to meet continual retail demand and accurately forecast our yields. And now I'd like to turn the presentation over to Dr. Fei Jia, our technical sales engineer for Heliospectra, and he's going to give us a scientific explanation of light quality and quantity.
All right, thank you, Alice. Hello, everyone. So as Alice mentioned, that the quality and the quantity of the light has a great impact on crop yield and the consistency of quality. So it's important to understand how the light works with the plants and how to quantify it. So the first concept I would like to introduce is PPFD. It stands for photosynthetic photon flux density. So what it measures is consider light as particles raining down your greenhouse or your grow area. And the light where the plants are using is anywhere from 400 nanometers to 700 nanometer, where 400 nanometer is about blue-green color and move gradually all the way to red, where 700 nanometer is. So within this wavelength of light, the plant can use those lights for photosynthesis activities. To measure the quantity of the light, we have to use a sensor called quantum meter to actually measure how many photons are collected on a certain area in a certain time. And the unit we're using to measure this quantity is micromoles per meter squared per second. So consider you're measuring water flow. So this is measuring the water velocity, how much water is passing by a pipe in a given time, given a pipe diameter, right? And also the location of the measurement is a key for greenhouse applications. As many of you might know, you can have this kind of data from a weather station measured outside of the greenhouse, but actually what you need to know is how much light you're getting inside the greenhouse. And because of the glazing material and the structural shading, you have to pick the right location to measure the representative light level inside your greenhouse. So this is the PPFD. The next concept is DLI. So what that stands for is daily light integral. So this quantity measures how much light in total is received at the plant canopy level. So PPFD, as I compare it to water flow, is the water instantaneous speed. The DLI you can consider as how much light is received during a day, during a 24 hours of period. So DLI is directly related to the plant growth, the crop production, and the quality of the fruits or the leafy greens. So as you can see in the slide on the right side, there's the DLI level for Ontario, Canada throughout the year. And in the chart in the middle, you can see the light requirement for different kind of crops. So let's say for leafy greens, you will need 15 to 20 DLI to ensure a healthy plant growth, and a minimum of 12. But in the winter time, because DLI is determined by season and also by latitude, the location of your greenhouse. So for example, Ontario doesn't receive enough sunlight for leafy green growth for 4 months of the year. So it has as low as 6 DLI. Here's where the supplemental lighting will come in to ensure the yield and the quality of crops throughout the year. So given the importance of keeping a consistent DLI level, HelioSpectra have our HelioCORE lighting control system on the market right now for exactly this purpose. So the HelioCORE system is a hardware and software combo to control the light to operate in a way, regardless of the location, will ensure your plants getting enough sunlight for the type of production you're looking for. So the HelioCORE system has 3 main functions. The first one is the on-target PPFD control that gives you a consistent level of light throughout the photo period. The second one is DLI control, so it will control the DLI level throughout the year for your production facility. And the third one is schedule. This is more for indoor grow application. So the first, the PPFD control, the way it works is we incorporate a sensor, a quantum sensor, to measure actually how much light is hitting the plant canopy level. And the HelioCORE system will automatically adjust our smart lighting to ensure the total amount of light is at the target that you set at the earlier time. So with more sunlight HelioSpectra light will dim more. With less sunlight, the HelioSpectra light will increase intensity to meet your target. So this is more like a passive control. And the second function, the DL light, that's the core of our HelioCORE control system, is the way it works is using its predictive algorithm. The HelioCORE was able to predict how to use the light ahead of time for a given day. So as you can see in the chart on the left side, the blue line is actually showing the natural sunlight for the day, and the red line is showing how the light will be operating to complement the natural light to meet your DLI level. So, yes.
Go ahead. Sorry, Faye. This was really critical and really interesting to watch as it happened in our greenhouse.
Exactly.
That algorithm, it really did learn to predict what our natural DLI was going to be. Once it had a few days in its logged history, it was able to adjust so that light period in the morning, it realized it didn't require that anymore, and then it would pick up at the end of the day if it needed to, but it didn't always have the lights come on first thing in the morning as it learned. It was neat to watch. Go ahead, Faye.
Right. Yes. Thank you, Alice. Yeah, that's the smart part of the HelioCORE BLI controller. It can actually learn how to operate the lights given your location. And also, on top of the predictive algorithm, it will also use the quantum sensor with the system to fine adjust the light level to ensure you meet the DLI level at the end of the day. On top of this, the HelioCORE also consider the utility price for your location throughout the 24-hour period. So we'll operate the light in a way to minimize the cost of electricity while the DLI level is still met.
We conducted a lot of research once we had HelioCORE lights in our facility with the University of Guelph. Research was done on our own crops in our greenhouse as well as in light chambers at the university. A lot of interesting results from this research will be presented at the Canadian Greenhouse Conference in Niagara this fall. So you can look for the research updates there. What we found in our own trials in our greenhouse was that we may be able to manipulate the stretch of our crops to facilitate faster and easier harvesting. We are also able to maintain the summer quality of our crop, both in color and in texture. And HelioCORE's automatic and immediate adjustments of light, it has become very critical to our crops. Yield differences can happen with our short cycles within hours. So HelioCORE has enabled us to use its real-time response to gain immediate control. As an example, this last winter we grew our biggest crop, arugula, under Heliospectra lights using a DLI control program. We were able to maintain very close to summer yields, and we required only a slight increase in crop time. In previous winters' experience of growing, it showed that other winters we nearly doubled our crop duration and only harvested 30% of our summer yields. So this winter we're hoping to see even better results than the last winter as we manipulate our light and our growing strategies further.
So by seeing these different ways of working with light and working with supplemental lighting, you're really being able to tackle these business challenges and see what reward you're able to get from these different types of control aspects. So here, I think relating a little bit back to the previous slides that both Alice and Faye talked about, so the really close correlation between the amount of DLI that you're getting naturally around throughout the year is so closely linked to production numbers and production forecasts for that year. So being able to increase this DLI level, you're able to increase your production rates, and also being able to standardize these yields throughout really the full year period, and also having a predictable crop time that can really vary in between different months. So here we see a graph representation of looking at the amount that you can really gain from working with supplemental lighting incorporated with an automated control system as well. So this really takes the guesswork out of the negotiations with your buyers by being able to really have a close grasp of the forecasting on your facility, which also gives you a really good crop consistency, and you know that you're producing the same amount of crop and with the same quality 365 days a year. So now we've talked a lot about the amount of light and the quantity of that, and then there's really such a close integration with the quality of light as well. So I want to highlight that really at this point in the webinar as well, that the synergy between the quantity of and the quality of light is really important. So we at HelioSpectra have been working with spectral variations and spectral control for many years, and we've built our product portfolio on the importance of providing the right light as well as the right amount of light to create the most optimal growing environments. And we've witnessed huge benefits for our customers with results that range from short harvest cycles to improved product quality and increased yields. And we're happy that we've incorporated this part also with looking together with the Greenbelt as well.
Exactly right, Karen. When we installed our HelioSpectra lights, we saw an immediate yield increase of 13% in our arugula crop. And we were able to maintain that cropping cycle throughout and remain very close throughout the year to being equal. And this is very critical to our business. Gaining control of predictable yields year-round, really, it decreases our input costs at seeding and our waste due to overproduction and compost. It has impacted our business greatly. Let's see. Let's move on to the next slide. Thank you. This moves us into success for our operations and sales. The HelioCORE control software, the fixture efficiency, and it has really helped us to further our business goals as well as our sustainability goals. Our production efficiency. Go ahead, Karen. Yeah.
No, sorry. I didn't mean to interrupt, but I wanted to add one part here on looking at what HelioCORE can really do on the integration of varying energy prices into the system as well. So in Ontario, so we've been discussing this a lot with Greenbelt in Ontario and in many other energy markets. So you have energy prices that fluctuate throughout the day, and so we can help you design lighting schedules that really maximize your light application when energy costs are the least. And in the DLI controller, since you're looking at a smart planning of the light to be able to complement your natural light, this is an automated process in the system. So you enter your energy prices, and then the system will always choose to place the additional supplemental lighting in the less costly hours. And we've seen that automated response has been a real benefit when talking to utility companies as well, to seeing that this is part of the system as well, that you're taking these prices into these types of incorporated processes as well. So on top of that, we can also help you identify the sweet spot of light-related energy use, where the correlation between the light and the crop performance, to make sure that the light that you use is really paying off in the end.
I agree, Karen. And after entering in that time of use energy information into HelioCORE software and observing the changes in the graph of our actual energy consumption, we were able to see a tangible difference within the control program itself. But ultimately, it is all about customer satisfaction. And HelioCORE lighting has enabled us to gain that year-round consistency of flavor, color, and appearance of our crops, and gives our customers confidence. This leads to increased sales, ultimately. Our retailers expect consistency of our crops for their own planning and orders, and repeat customer sales are realized when our customers know that they will be always buying the same reliable product. And
so,
go ahead, Karen.
Sorry, and I wanted to add to say, this is another point that we really connect with Greenbelt on. We mirror this as our main goal in working with our customers. It's really to provide the best products and systems that are consistent and have the highest quality, and for them to be able to rely on and be able to keep their customers stocked with a consistent crop production as well.
Thank you so much again for joining us today, and thank you to our speakers and to HelioSpectra for sharing this information with us.